Hello, everyone. Welcome back to more Advent of Code in March of 2023. We're doing the Advent of Code 2022. I thought of this earlier, and I forgot to follow up on it, and I'm literally seeing just now that my package name is 2023 because this is the year I'm doing it in, and I made the package name. Well, I'll have to. I made the folder right, and it's the GitHub project is right. The package is wrong. Very funny. Well, I'll have to change that at some point. Actually, maybe it's just really easy. Maybe I can just refactor, rename, preview. I don't know. It seems like it might work. I don't want to do it right this second though because I have a couple bits of cleanup, I guess, from yesterday's puzzle that I thought of. If we look at the diff of the current file, why is it so slow? It's on disk, right? Anyway, I had a few things I didn't like. Oh, okay. There's a lot of shit in this diff for no good reason. In the process of doing this refactoring here, I added a new import of Java util stream collectors joining because, and let's look at that first, this bit here where we say map poll last and then join to string with separator whatever, this is in principle a little bit more expensive than it has to be. Obviously, performance isn't a big deal in Advent of Code, but I like trying to find the way you should do things, right? And this map on a list, right? It takes a list or an iterable and produces a list. That's materializing an intermediate list for no reason, right? I just want to turn it to a string eventually. So I did it. I said, I should do this the way that you would do it in Java instead, which is to stream over the list of stacks, map converting each of them to a string. Apparently, joining only... There's a collector named joining, which only collects character sequences. So you have to include a toString in the map call, whatever. Although, isn't that kind of expensive? No, I guess not. You have to do it anyway. Well, I don't know. This is materializing a bunch of intermediate strings I don't need, whereas this... I guess you couldn't help it, because all you really have on a queue is toString anyway. Anyway, the point is, and then I collect with just joining, saying, when you're done, turn this whole stream into a string, and it comes out lovely. But this introduced an import of joining, which is fine. I want that import. But IntelliJ's default settings were to say, you're importing several things from Java util? Let me just replace that with Java util star for you. And I was like, if you ever do that, I'll shoot you in the head. And I had to go digging through all the settings to figure out where the hell do you change the import style. And I finally found all the code style settings. And so I made a couple of superficial changes to make myself feel smart and important. For no good reason, really. This is interesting. It also changed the import here. I had it as array deck. Is it... I guess it's somehow using the right one here. I thought I put this in because it was necessary, but apparently it wasn't. Anyway, so I made a couple of code style changes, none that are terribly important, but I kept accidentally typing this space here, and I figured why not make it the law. Did I make any other style changes here? No, I think this is all just the same style change over and over. I also observed that giving this a name was pointless, so I got rid of it. And this for loop really should have just been a for each. Just a little bit simpler. Anything else that actually changed? Doesn't look like it. So that was what I actually did. So if I go to Git, I think there's going to be some other changes, right, in my No? I thought I had some changes. All right, whatever. There are some changes I was thinking of making in my library file, but I guess I didn't make any of them. Okay, so let's just commit that. Except the thing is, I really should do the style changes separate from everything else, right? I'm not smart enough to do that. So this is day 5. Minor cleanups and style change. And I wonder, if I look at this, okay, so now is when we wanted to rename this package. 2022. Has it happened? It has. Great. Look at that. These haven't gotten my style changes. Is there a way? I don't know. I can just open all the files and hit save. I also changed it to, okay, so let's say fix package name, apply style changes throughout. Oh, I didn't open input and save that. No, it looks like it happened anyway. Great. What was I saying? I don't remember. All right. Well, great. Good to know that whatever that was, it wasn't important. Let's get started on day 6. Tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way towards the Starfruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard that you have significant experience dealing with signal-based systems, he convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. Okay. In the protocol being used by the elves, the start of packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. It needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. For example, suppose you receive the following data stream buffer. Yep. After the first 3 characters have been received, there haven't been enough yet to find the marker. Fine. The first time a marker could occur is after the 4th character is received, making the most recent this. But J is repeated, so this isn't a marker. So after the 7th character arrives, which is this M, we have J, P, Q, M, and M is the start of the thing. Sure. Yep. All right. It's a long data stream input, all right. So we can make this new file here. Day6.txt. That says 7. We'll go ahead and add it. I'll just rename it in a sec. Okay. Great. Oh, do you think there's a typo in here? Should I, you want to try, oops, wrong button. What did I do? Oh, I switched, okay, whatever. It's underlining this, but it can't even bear to, if I ask for suggestions, it like freezes my computer. Great. Okay, so let me just paste that again in case I screwed it up. Wow. it really does not like a long line. Hello? Okay. So let's never look at this file again. New Kotlin file day 6. Sure, put it in Git. Wait. All the rest of these I've been putting in new packages. I forgot the package. New package. Day 6. Put this there. Yes. Okay. So I think first we need to think a little bit about the algorithm. I can think of two obvious approaches. Well, okay, I guess three. One thing you could do would be to just like to have an int that represents the index and keep counting that upward. At every step, look up a sublist of the or substring, I guess, of the input that is like I to I plus 4. 4? I think so. Yeah, we need 4 things. And then scan the string that the results from the substring and see if they're all the same, if they're all different characters. That certainly is possible. I don't like it because it deals with indices so much. That is kind of a habit that I got from my Clojure and Haskell experience, is that indices, indicate non-functional thinking, usually. It's better to process data as a stream, or sequence, or lazy list, or whatever, when possible, because that lets you build on stuff like map and reduce and all this stuff, and it doesn't involve retraversing the list. Now here, our string is random accessible, so indices on it aren't that bad, but it still involves like mutating the index, counting up, counting, whatever. So, I guess it doesn't have to. You could operate on a stream of ints, I guess. But so anyway, that's one thing we could do. Another thing that seems cute is to have like a ring buffer of size 4, where we just keep shoving elements into it, and then when elements fall off the end, they just disappear. And every time we push an element on, we see if all the existing elements are different. Now, that's fine. It shares a flaw with the... I don't know. Let's not talk about that flaw yet. The third approach I had in mind was to split the string into groups of 4 adjacent characters with overlap. So if we have like the string, A through G or whatever, the first chunk is A, B, C, D, the second chunk is B, C, D, E, next is C, D, E, F, and so on. I don't know the right way to do that in Kotlin. In Haskell, you could like zip a string with its tail, but like you have to do that 4 times, which is a little unpleasant, and get out a 4 tuple. In Clojure, it's easy. You would use partition with a size of 4 and a step of 1 to get chunks. Probably Kotlin's chunks of function does that, or chunked or whatever. Let's find out, actually. Fun main. So what happens if I say dot chunk These actually have just sizes. Well, anyway, this is not exactly the most performant option anyway. And they all have this flaw that I have in mind, which is that you need to iterate over the 4 characters in the string to detect whether they're all the same. And it's not that bad. You can just make a set, right? And, add, or, a multi-set or something, add all the elements to it and see if anything has a size greater than 1. Or, I guess you would add a set and see if it has a size equal to 4. That's what you would want. And that's fine. But it involves reprocessing the same characters over and over, right? If we have... Hello? If we have A, B, C, D, E, F, then what do we process? First we process A, B, C, D. Then we process B, C, D, E. Then we process C, D, E, F. So, like, there's duplication of work. We're processing every character 4 times, right? That's fine. It's a small constant factor, but, like, wouldn't it be nice to think of an algorithm that doesn't have this weakness? What if part 2 is something like, well, you have to look at sliding windows of 1,000 characters at a time? Probably even that you could just brute force your way through, but it would be nice to think of something cool, wouldn't it? And I don't think it's that hard. If we look back at the ring buffer approach, we can basically say every time you evict a character, note what it was. And basically just keep a multiset that is sort of in parallel with the ring buffer itself. Right? Does that make sense? I think so. So whenever you add a character to the buffer, you put it in the multiset. When you take a character out of the ring buffer, you decrement its size in the multiset, which may involve deleting it. And then you check, like, does the multiset have 4 distinct items, or only some smaller number? And that, I believe, is going to take time logarithmic in... Well, I'm so used to thinking functionally. Maybe it's actually linear, but... Instead of taking time linear... Sorry, maybe it's constant. Instead of taking time linear in the size of the window to scan, you take time, however long it takes to ask... To update a multiset is how much time you end up taking. So I assume the multiset is at least log time and maybe constant time. Like amortized constant kind of thing. Almost nothing, functionally can be linear time when you're working with a data structure. It has to be log time. But here we're actually mutating something in place, and it could plausibly be constant time. So maybe. So I want to look up, like, can you use an array deck as a ring buffer? Is that easy or hard? Oh, sorry, I didn't... Okay, I'm still not used to, like, alt-tabbing with this setup. So if we said javadoc array deck, which is all in caps because of... It's in my search history from when I accidentally had caps lock on. What version of Java are we using? 19, by the way? Yeah. So here's the javadoc for array deck again. And what happens, by the way, if you call, like, add last and it's full? I assume it blocks or something? No. I think array decks... Oh, they have an unlimited capacity. They're unbounded. Okay. So if we say like Kotlin ring buffer, like what do people recommend? Here's some random GitHub repo. Here's a textbook. Circular array? That's an Android thing, apparently. I mean, we can just use an array deck and manually manage the size ourselves, but wouldn't it be nice if we didn't have to? Yeah, I don't know. It doesn't look like there's anything actually good. Okay. So that doesn't exist. That's fine. It's not in Guava either, is it? Guava ring buffer. Evicting queue. Ah. This might be what we're looking for. Non-blocking queue, which automatically evicts when attempting to add if it's full. It's a circular buffer. Must have a maximum size. Automatically removes its head element. Okay, so do we, when we add something, do we get like... We don't really get access to the thing that was removed. It's just removed. Right? Yeah. So we don't, I think, really want this. We can just do it ourselves with an array deck. An array deck and a multiset seems like the way to go. I'm just briefly like thinking about how stupid this all sounds when like obviously the approach of splitting things into substrings is going to be fast enough and much simpler, but boy, isn't this an interesting thing to do. And you know what? I'm doing Advent of Code to do interesting things, so that's what we're doing. So I guess what we can just say is val. I mean, we can say read input. That's fine. Of day 6, and I mean, I guess we could just say 0. Val. What is this called? Stream? No, that's a terrible name. Packets? Great. So that is a single string, right? Yes. I kind of can't think of anything that needs to be done like globally. I have no idea what part 2 is going to be. Probably it's going to be like, okay, after the start of stream, these bytes mean something totally different. So read the stuff that comes after this. But for now, well, I don't know. I guess I can just write a function called start of stream that returns an int, and then in part 1, I'll just call that function and return the result. We need a function start offset. Aha! You thought I was going to say start of. No, I was saying start offset. Takes a packets, which is a string. It's gonna. There you go. Put that space in there for me. What a deviant. And let's say we'll take a size parameter as well, since the whole point of this is to be parametric and indifferent to what the size is. Sync packet size, which is an int. We need a couple of things. We need a multi-set. I think, do I want to say multi-sets dot? No, it's, you have to say like hash multiset dot create or something. Yeah. Distinct elements. I mean, I predict there will be 4. None of them can be called. I mean, I know you don't have enough information yet, but you'll get it later. Give me a break. Val present is this. And val, let's call this counts. Val buffer is array deck of char. Can I specify a size or something like that? Probably. What if I just say 4 here? Yeah, great. Not 4 though. Sync packet size. I mean, I think I shouldn't have to specify this either, right? You'll figure it out when I start putting chars in there, yeah? If I said buffer dot add last A? Did you figure this out? No. Apparently you need the information more locally. That's fine. I'll give it to you now if you insist. That's what she said. So I think at this point, I need like functions, you know, a function that says consume character or something, right? A function that modifies counts and buffer. So let's say next takes a char. And it probably returns something, right? It should return like whether it was unique, yes? I don't have a good name for this. So basically we say if, well, no, let's see. If buffer dot size is equal to the sync packet size, only then do we evict something, right? Then I guess we just say buffer dot take first? No, it's not take, it's poll. Why are you offering me all these weird functions? I want the ones that are on buffer. Oh, fuck. This is the weirdo Kotlin array deck. Okay. I mean, I guess in this case, that's probably fine. Except I have to learn the API for it. Remove first probably is what I want, though. Fine. Evicted. Then we can say counts dot. How do you change something? Is you just call remove? It's possible, I guess. Yeah, just remove, yeah? And I only want to remove one occurrence of it. Evicted. In fact, I can just inline this, right? Counts.remove of buffer.remove first. Right? That seems fine. Then we say buffer dot. How do you add last? Sure. Of C. And counts dot add of C as well. And then I guess we're returning whether return whether counts dot. I don't know what'll happen if I say size. I mean, I can look at the docs, I guess, but I don't think that's what I want. I think I have to say like as set dot size basically. Or element set, I guess. I guess element set, right? This is a set of char. It clearly can't have, okay, size equal to sync packet size. Yes, go ahead and update the return type. And let's change this to, I don't know, I guess next. Ugh, I kind of hate it. Because it's mutating, it's doing a next thing, but it's also returning useful information. Like, what do you call that? Consume and check for start. Sync? Consume and check for sync? Sure. So, I think this is basically how we're supposed to... Like, this makes sense, right? We only remove something if the buffer is already full. And if that's the case, we also remove it from the counts. Then whether or not the buffer was full, we add the item to both the buffer and the counts. Oh, yeah, and we put last in counts, and where we put it in buffer, and where we put it in counts doesn't make any sense because it's a multi-set. Okay. So now I have this function I can use. And isn't it just very easy? I say packets dot chars dot, I don't know. Can I like index it or something? I don't know. I don't really want I don't really want it as chars, right? I want packets dot... I want to, like, iterate over this, I guess, right? C in packets. But I don't quite want to do that, right? I want to iterate with... I want to, like, map indexed over it, right? So... How do you... Java stream, like, map indexed guava? Like, there's something like that, right? How do you iterate over a stream with indices in Java 8? Is there, like... What? Sorry, I guess I can show you guys this. I'm not convinced that this is the right answer. Start from a stream of indices. No, this is horrible. What if I didn't have an array to begin with? You sicko? Who upvoted this 500 times? Can't get the index. It also lacks the ability to zip together? That might be true. I know you can do it in Guava. I think you can do it in just like slightly more modern Java. Oh, here we go. I've uploaded this. Streams up map with index. Amazing. Thanks, Guava. What a bro. What's going on this issue anyway? What even issue is this? For each with index? I don't know. Who wants this? Have I commented on this? No. Okay. Not that I want to. But since I was on the Stack Overflow question, it's plausible I would have commented at some point. Cool. Well, we're using Guava 31, so this should be around, yeah? Map with index. So if I say... I don't want to iterate like this. I want to say packets.chars.map to obj of it dot to char. And then I want to take all this and I want to say map with index. Can you find this for me? Yes. Good. Okay. Map with index. It takes a stream first. And then I do this. Is that correct? Like, what? Is that allowed? You don't like this. Type mismatch. Oh. Why? Do I have to specify what these are called? I guess I do. CI to this? Good. But, like, please give me a static import of this. And, like, really, it might be reasonable to say, to put this at the end. In the same way that, like, with Clojure, you get the arrow operator that lets you, like, say, do some, like, prefix notation, like function application notation. You end up having to say, like, f of g of x. And, like, you do g first, but it's written second, and it's a little confusing, right? And that's one reason that people like object-oriented languages, dot notation, function chaining, where you say, like, do this, dot, then that, etc. In Clojure, you can use the arrow operator to let you kind of say, okay, do this, and then do that, even, and it rewrites it to the prefix form. Kotlin has a similar tool that we used once, or more than once maybe, where I could have said, actually I bet it'll even show me, right? No? Why can't I do this? I mean, it's fine, I guess, that I can't. But I thought, like, I could say use let. Like, if I... Right? Huh. Anyway, if I wanted to, I could say this dot let it dot map with index, whatever. No? Oh, right. I would still have to write map with index of it. Right? So, like, you know, is this better? Maybe. It is kind of nice that then I get to write, like, you know, I do all this and then I say map with index. Sure, let's write it this way. Why not? And then we basically just say, well, I'm just realizing now I want exactly what that Guava issue was saying. But I don't, right? Because I want to... Streams are tricky. Because side effects in streams are tricky. Because it doesn't really guarantee how much of the stream will be processed. I think in practice it won't actually be more than one element at a time. I guess it's fine. I could even modify... Yeah, okay. So we'll basically just say... consume and check for sync of C. Oh, do I not want map with index? I guess I don't. Okay, well that's interesting. I need indexes at some point, but I need, like, filter with index? Does that exist? Filter with index? No. So that doesn't exist. But that's okay, right? Because now I have a stream of bools, right? And now I can say map with index of it done, oops, done I to I guess I just want a pair? Like, I want an optional int, I guess. Yeah, maybe that makes sense. So if done, then I guess I can say when. Done to optional dot of. Oh, actually, is there a flat map with index? There must be, right? Oh, flat map index? That takes sequences. Does this not exist? Oh my god. That's fine. We'll just use map. Are you kidding me? You don't know? You need me to specify I want to import optional? Fine. So now we have a stream of optionals of ints, which are the indexes. And we can say flat map of optional stream. What are you upset about? Oh, I opened braces, but I didn't want that. Really? I have to specify optional int? What? Is this supposed to be a long? Are these longs in here? Is that Kotlin's default integral type? It stopped complaining. Okay, great. So now I have a stream of ints, and I just want the first one. Find first. Or else throw no start, no sync sequence. This is really how it's supposed to look? Google Java format would have a heck of a fit if this were Java code. What about my rectangle rule, man? All right. So this should return an int, right? Oh, I have to say return here. Now it's upset. Oh, it's a long. I mean, that's fine. I don't care. I'm kind of confused about why it's a long. Oh, map with index must introduce longs, right? Okay, forget that. I want ints. To int, I assume. There we go. I mean, I think they do have, like, optional long or some insane thing like that in Java these days, right? They do. And, like, if we really cared about performance, we could use that here instead of an optional .of an int. Or likewise optional int. So, like, maybe this whole function just works despite us not having tested or interacted with it at all? It's possible. And if it doesn't, we'll just run it through the debugger, right? So let's just try printing it. Print line of part one of, actually, well, let's just say start offset of packets. Oh, that's kind of nice. I know it like sometimes puts these indicators here on like what the parameter is. It only just now clicked with me that it does that when you're specifying, when you're passing a value that's like not very self-descriptive, right? Like a literal or something. And it's saying, okay, someone reading this code might not know what the 4 is. And so they're labeling it sync packet size. Whereas here, packets, it's obviously just packets. So, right, if I were to instead say this, it would throw that in. That's nice. Let's just run this and see what happens. Actually got a number out. 1722. That seems suspiciously long. Just in case, let's print on size packets dot size, right? Dot length. Like, I'm just the tiniest bit suspicious that this might be the end of the stream. It's not. Okay, cool. Well, let's give it a try, I guess. Where am I? Not here. Right? Yes, wrong window, wrong window. You guys are seeing the right window. I just have to figure out where the hell on my screen it is. So let's just... Okay. Actually, I should check for off by 1 errors. There's an off by 4 error I can already see. To the end of the first such 4-character marker. So, okay, here's our example. Well, where's our very first short example? First 3 characters, okay, so after the 7th character, which is this one, so 1 indexed, 1, 2, 3, 4, 5, 6, 7. Well, wait, maybe this is right. We've pushed 7 characters, right? So I guess when we got to this, the index was 0. When we got to this, the index was 6. And we completed. So really, I should be adding 1, I think. So let's just... plus 1! Okay, there you go. That's very legible and not at all sneaky and hidden at the end of the function. We'll run it here and we'll get, 1723, but... Just in case, I'll run it to see if math has changed. No? Okay. $17.23. That's the right answer. Oh. Can we call this working on the first try? Do you think that's accurate? It ran successfully to completion on the first try, produced a number that was off by 1, but then I looked at it and said, let me just check the specs real quick. And it was wrong, and I changed the implementation, and it was right. I feel like I deserve some credit for that. We'll call that working on the first try. So let's just commit this then. Hello? Get bookmarks out of here? I don't even know what that means. Day 6, part 1. Okay, back to Advent of Code. Oh, perfect. We built exactly the right tools. It still isn't working. It needs to look for messages. Yeah, but there's actually 14. So great. This is exactly what we did. I'm so pleased with myself. I see. It's my hotkeys to change what window is showing are getting processed by IntelliJ. So, incredible. I'm a super genius. And we'll just say 14, and we'll run it. At least it didn't. I mean, if it asked for 100, that kind of would have been impossible, right? Because we only have 4,000 things, and more importantly, because there aren't 100 distinct characters in the alphabet. But we're more efficient. We're doing 14 times less work than if we were doing something less efficient, right? So let's just write that number in. That's the right answer. Amazing. Cool. Well, I'm happy with that. Oh, except I should say part 2. Great. Get this shit out of here. Before I was doing the whole display capture thing, which I, again, hate, in order to make sure you guys could see the tooltips, I was getting around this issue by issuing those keystrokes while focusing on a different window than IntelliJ. I would go click on OBS, but then you guys see this. So I'm not doing that. I'm issuing the keystrokes directly to IntelliJ to focus it, to only show it once it's the right part of the screen. But anyway, you don't care. It doesn't matter. Git commit. Part 2. Genius. We don't really need this size. We could remove this. Let's do another commit. Day 6. Remove size by Yes, this file. And let's just push. Sometimes I forget to push after the video, and it would be nice to just have it all pushed. Sure, push all that garbage, see if I care. It's pushed. Hope you guys enjoyed. Thanks for watching. Oh, no, hang on. Let's just review. Is there anything here that I didn't like or that we should do differently? I don't think so. I think this is savant level coding. I could probably get a job as like head engineer at any tech company with this function. They might complain about the name of the helper function. Yeah, a hash multiset and array deck. I think these are exactly the right tools to use. Parameterizing on sync packet size paid off exactly, even though I thought that wasn't what part 2 was going to be. It actually was. And I designed for flexibility because that's what I like to do, and it turned out to be important. This, I mean, it's a bit of a mouthful. This is the Java way of doing it for sure. You know, is there a better Kotlin way? Maybe. If I took this list of the stream of chars and made it into a sequence and used sequence functions on it, maybe that would work well. But I'm just going to celebrate that we're done. So, hope you guys enjoyed. Thanks for watching, and I'll see you next time.